Assalamualaikum warahmatullahi wabarakatuh. So I'm gonna presenting artificial intelligence method about Twitter sentiment analysis for my final exam data mining created by Rangga Marlansyah. The goal: solving NLP task and break down how it works, and then answering all questions with the best answer as I could. The research: given the dataset about positive and negative comments from Twitter, and I'm gonna classify them into its right place. The method that we're gonna use is NLP methods. This is a field of artificial intelligence that is concerned with creating a means of communicating with intelligent systems using a natural language such as English. But our data right now is bahasa. So the first one, exploratory data analysis. Getting word frequency in the gram with highest value, top 10 in each categories. So here it is, the positive one. The top 10 unigram for positive is yang dan nya, orang, mereka, Allah, tidak, dari, kepada, dengan. And then for the top 10 unigrams negative is anjing, Viking anjing, persib, yang, nya, tidak, sama, bangsat, dan Bandung. This is the word cloud for positive and negative. Next one, getting word frequency bigram with the highest value top 10 in each category. The top 10 positive word frequency B for bigram is orang, yang, orang-orang, nya, dan, apa yang, sallallahu alaihi, Allah subhanahu, kepada Allah, yang tidak, kepadanya, dan tidak ada. And then for top 10 negative bigrams is Viking anjing, anjing persib, anjing Viking, persib bangsat, bangsat Bandung, Bandung kota, kota maksiat, Viking bonek, itu anjing, anjing bulu. And this is the word cloud for positive and negative bigram. Next one, getting word frequency trigram with highest value top 10 in each category. So for a top 10 positive word is orang-orang yang Allah Subhanahu firman Shallallahu Alaihi Wasallam, Rasulullah Shallallahu Alaihi, Nabi Shallallahu Alaihi, orang yang iman, dan orang-orang Shallallahu Alaihi Wasallam, orang-orang kafir. For top 10 negative digram are Viking anjing persib bangsat, persib bangsat Bandung, bangsat Bandung kota maksiat, anjing Viking anjing anjing bunuh saja. Bilang Viking anjing, Viking itu anjing. And this is the word cloud for positive and negative digram. The next is pre-processing. Text pre-processing is an important step for natural language processing or NLP task. It transforms text into a more understandable form so that machine learning algorithms can perform better. So here are the steps: handling stop words, stemming, lemmatization, and removing slang. Lowercasing is lowercasing is each text is converted to lowercase, and then replacing URLs, linking starting with HTTP or HTTPS or www are replaced by URL. And next one, replacing emojis. Replace emojis by using a predefined dictionary containing emojis along with their meaning. Replacing usernames, replacing usernames with the word user. And then removing non-alphabets, replacing characters except digit and alphabets with a space. And then removing consecutive letters. 3 or more consecutive letters are replaced with 2 letters. Removing short words. Words with a length less than 2 are removed. Removing stop words. Stop words are The bahasa words which does not add much meaning to a sentence. They can safely be ignored without sacrificing the meaning of the sentence. Lemmatization is the process of converting a word to its base form. So this is my code for cleaning text data, and the output for the clean text is right here. Factorization, TF-EDF. Term frequency or TF, number of times term T appears in a document per number of terms in the document. Inverse document frequency or IDF is log n per n, where n is the number of documents and n is the number of documents a term T has appeared in. The EDF of a rare word is high, whereas the EDF of frequent word is likely to be low, thus having the effect of highlighting distinct words. This is my code for TF-EDF. Next one is MinDF. MinDF, it is an integer of float from 0 to 1, representing the minimum number or proportion of documents a term must appear in to be included in the vocabulary. If the term frequency is below this threshold, it is ignored. For example, if MinDF is set to 2, a term must appear in at least 2 documents to be considered. MaxDF. It is an integer float from 0 to 1, representing the maximum number or proportion of documents a term can appear in to be included in the vocabulary. If the term frequency is above this threshold, it is ignored. For example, if MaxDF is set to 0.8, a term that appears in more than 80% of the document will be ignored. MinDF and MaxDF. These parameters are used when creating the TF-EDF matrix to filter out terms that are too rare or too common. Adjusting MinDF and MaxDF helps in controlling the size of the featured vocabulary and can improve the model's performance by removing noisy or uninformative terms. Modeling support vector machine. Margin is the gap between the hyperplane and the support vectors. Hyperplanes are decision boundaries that aid in classifying the data points. Support vectors are the data points that are on or nearest to the hyperplane and influence the position of the hyperplane. Kernel function, these are functions used to determine the shape of the hyperplane and this decision boundary. This is my code for supervector machine. Next one is multi-word expression or MWE. In natural language processing, MWE stands for multi-word expression. It is a sequence of words that have a collective meaning, often different from the meanings of the individual words considered in isolation. These expressions are treated as single units or entities during linguistic analysis rather than as separate words. MWEs, including various types of linguistic constructs such as idioms, collocations, phrasal verbs, or compound words, and other fixed or semi-fixed expressions. Here are some examples. Idioms, expression where the meaning is not deducible from the individual words, such as kick the bucket, meaning to die. Collocations, words that tend to occur together frequently, like strong coffee or make a decision. Phrasal verbs, verbs combined with preposition or adverbs to create a single semantic unit. Example, give up, look after, and then the common words formed by combining two or more words such as software engineer or blackboard. This is my code for NLP. TF-EDF. This is my result for TF-EDF. Values are predominantly zero because most words don't appear in every document. And for non-zero values indicate the importance of term within a specific document. This is grid search cross-validation. And for the evaluation matrix, the model has performed exceptionally well on the test dataset, achieving perfect precision, recall, and F1 scores for both classes, and an overall accuracy of 1. This suggests that the model is accurately classifying instances in the test data. However, it is also important to be cautious about potential overfitting, especially if the model has not been evaluated on unseen data. And thanks for your time. Uh, I'm sorry if there are so many mistakes. Wassalamualaikum warahmatullahi wabarakatuh.